School of Engineering, Department of Mechatronics Engineering, online classes, analog devices and circuits, unit number 3. Okay. So in unit number 3, so we are going to discuss about the waveform generators and special function ICs. Okay, so that is we have a different waveform generators using operation amplifier. In first unit, we discussed with the oscillators, which is done by the BJT. Here we are going to generate the signals, that is waveforms using these operation amplifier. So let's see one by one. First one, triangular wave generator. The signal generator gives two waveforms, a triangular wave and a square wave. The central component of this circuit is the integrated capacitor. Basically, we are interested to perform in two functions on CA. One is charge and discharge and repeat indefinitely. So this is a basic model of the execution of a triangular wave and sawtooth like that. Okay. So this is the block diagram for the triangular wave generation. So that is, here we have two models. One is triangular model, another one is the integrator model. So that is, we are generating the square wave and we are giving to the second integrator. So you will get the output of triangular wave. So sawtooth waveform generator. This sawtooth waveform oscillator, which is used to operation amplifier, the composition of the circuits is the same as the triangular wave oscillator. Basically, is used to two operation amplifier. Yeah, the circuit diagram, schematic trigger is the integration circuit. The difference with the triangular wave is to be changing the time of the charging and discharging of the capacitor, because in triangular the capacitor will linearly charge and linearly discharge. Okay, but in schematic trigger it will be linear charge and rapid down to the zero. So this is the difference between these two. Okay, so this is the model of sawtooth waveform. So that is the, here they are using the diodes. Diodes will set the zeros. Okay, triangular wave diodes set the zeros. So that is, when capacitor charging, it goes to the maximum value. So it will goes to the zero done by the diode, because the less than value will not be given to the circuit. So the capacitor will not be linearly discharged. So when picturing the picture at the cathode ray, so triangular waveform oscillator, the line voltage need to both the positive power supply and the negative power supply. So to work in the oscillation, the condition of the R3 greater than R4 is necessary. However, the making the value of R4 is small compared to the R3. So the final frequency will be F is equal to 1 divided by 2C of R1 plus RF into R1 R3 divided by R4. So this is a basic oscillation of the sawtooth wave. That is F is equal to 1 divided by 2C R1 plus R2 into R3 divided by R4. The output will be 56.8. So next one, sine wave generator. Here we are going to discuss about the RC phase shift oscillator and Wien beat oscillator. RC phase shift oscillator basically consists of the amplifier, and the feedback network consists of resistor and the capacitor arranged in the ladder fashion. To understand the operation of this oscillator, so let us study RC circuit first, which is the used to feedback network. So the capacitor C and the resistance are in the series. Now X is the capacity reactance in ohm given by. So X is equal to 1 divided by 2 pi FC. The total impedance of the circuit is equal to R minus JW XC is equal to Z less than minus RC feedback network. As stated earlier, the RC network is used in the feedback path. In the oscillator, the feedback network must introduce a phase shift of 180 degree to obtain the total phase shift around a loop as 360 degree. Thus, if one RC network produces the 60 degree, then to produce a phase shift of 180 degrees, such as the three RC network must be connected in cascade. Hence, in RC phase shift oscillator, the feedback network consists of three RC sections, each producing a phase shift of 60. Thus, total phase shift due to the feedback will be 360. Okay, the network is also called a ladder hookup. So all the resistance values and all capacitance values are same. So that for a particular frequency, each sections of R and C produce a phase shift of 60. The RC phase shift oscillator using op-amp uses an op-amp in inverting mode. Thus, it is produced introduce the phase shift of 180 degree between the input and output. The feedback network consists of three RC sections, each producing 60. The output on the amplifier is given to the feedback network. The output of the feedback network divides the amplifier. The total phase shift around the loop is 180 degree. The amplifier and the 180 degree 3 to 3 RC section. So that is 360 degree. This satisfies the required condition for positive feedback and the circuit works as the oscillator. So this is the model of RC phase shift oscillator with the operational amplifier. Okay, here we are connecting the feedback network area. We are connecting the RC phase shift network, that is three capacitor and the three resistors. So this is a derivation for phase shift oscillator. So final output will be frequency, that is output frequency of the sine wave waveform generator F is equal to 1 divided by 2 pi RC and root 6. Okay. So advantage of RC phase shift oscillator. The circuit is simple to design, can produce output over the audio frequency range, produce sinusoidal output waveform. So it is fixed frequency oscillator. So we cannot vary any frequency in the output. Disadvantage, by charging the values of R and C, the frequency of the oscillator can be changed. But the value of R and C of all three sections must be changed simultaneously to satisfy the oscillating condition. But this is a practically impossible. Hence, the power shift oscillator is considered as a fixed frequency oscillator for all the practical purposes.